All right, greetings, YouTube. This is Beautiful Mind here answering a question that was sent to me. So this comes from, I think it's Pre-Calculus Essentials by Lyle Hornsby and McGinnis. I think this is just Pre-Calculus Essentials. It comes from section 4.2, question number 9. And the question states, the variable t is a real number, and we have that p, or the terminal point, is going to be given as such. Is a point on a unit circle that corresponds to t. So that's the charge is to find the exact values of the 6 trig functions of t. So now, if this point P is a point on the unit circle, then we know off the bat that this is going to be our cosine of theta, and this is going to be our sine of theta. Okay, so notice that we went a positive direction and then negative, so that means we're in quadrant 4, so we're going to factor that kind of stuff in as it comes up. Okay, and then if we're on the unit circle, we also know that it has a radius of 1. So some equations that could pop up in this discussion, we can use x squared plus y squared equals r squared. We know that the radius is 1, so that's one thing. Or we can use sine squared theta plus cosine squared theta equals 1. So we can kind of use these notions. So I'm kind of doing this off the cuff, so let's see how it evolves. Now, I'm under the impression, let's see, we have this terminal point and we're on the unit circle, so my first mind tells me that, and it says to find the exact values of the 6 trig functions, and we just label this point cosine sine. Okay. So my first inclination is saying, okay, maybe sine of theta is going to be this negative 1 by 5. All right, and then the cosine of theta would be this 2 root 6 by 5. So it's like it's just given to us because it's on the unit circle, and we didn't have to, the radius was 1, so I think we're good to go. So this means that tan of theta, which is going to be sine of theta over cosine of theta, that's going to be a negative 1 by 5 over 2 root 6 by 5. So then the 5's cancel, and we get negative 1 by 2 root 6. And if we were to rationalize, multiply the top and the bottom by root 6, then we would have root 6 over 12. So we'd have a negative root 6 over 12 for tan of theta. And notice if we make a line through the origin and through our point, since our point is in the 4th quadrant, that means that this line that we create would have a negative slope. And in class, we discovered that tan of theta is going to be the slope created with the origin and our point on the unit circle. So notice that this is a negative slope, so that kind of confirms that that notion. Let's keep going forward, and we'll kind of try to create some confirmations. Okay, so now if these 3 are correct, once you have sine and cosine, it's usually pretty easy to find the rest of them with a question like this. So then next, the cofactor or cofunction with sine, the one that goes with sine is what? Cosecant. So then cosecant theta will be just the reciprocal of sine. It's going to be negative 5. So then secant theta is going to be the reciprocal of cosine. So, we can do 5 over 2 root 6. And if we were to rationalize, it would be 5 root 6 over 12. And that's fine with me. And then cotangent theta is going to be the reciprocal of this. So it should just be 2 root 6 negative. Okay, so now we have the solutions above, or some of the solutions above. I'm just going to do a quick scan. Okay, negative, so sine of t. So I was using theta, so we should have used t, which is fine. So sine of t would be a negative 1 by 5. Cosine of t would be 2 root 6. Let me see. Yeah, this looks like what we have. Okay, so the only change that we should probably make, let's do this, that, that, almost got them all. I want to get rid of these. I want to get rid of that. And I want to get rid of those. And then that guy. And that guy. All right, I think I captured them all. I'm going to delete or delete them. So all of those need to change to t's. So we'll make that change. Okay. I just tend to use theta because it's easier for me to see and keep track and have an idea of what I'm talking about. Okay. So this is my claim. All right.